All right, in this lesson, let's learn about multi-dimensional arrays. If you're having a hard time conceptualizing a multi-dimensional array, then think of it as a Rubik's Cube, where each cube that's combined to make the entire structure is a number. In our example, visualize each cube as a number, not the different cube faces. So, the first cube we see projecting outward towards us is 3.2. Each side is not 3.2, the entire cube is 3.2. The lines on the cube represent a one-dimensional array if we're reviewing just these cubes in isolation. Horizontally, we have three cubes, a 3.3, a 1.8, and a 3.2. These cubes in isolation are a one-dimensional array. Vertically, we have 1.8, 2.8, and 4.5. Again, these are one-dimensional arrays on a different plane, and that plane is a vertical plane. The next plane is horizontal, but projecting into another dimension, the third dimension. This is a multi-dimensional array that's also called a tensor. These numerical tensors are the objects that move through the graphs. Imagine different operations being performed on these tensors as they flow through a graph. That's why Google named the product TensorFlow. And you have to admit, it's a lot easier than saying multi-dimensional array flow. All right, in this lesson, let's learn how these tensors flow through this computational graph, the flow part in TensorFlow. In TensorFlow, everything is a graph. The tensors you define in Python represent the edges of the graph. Edge is a term Google uses for these tensors in the graphs. A TensorFlow program is a graphical mode of your solution. This group of edges and nodes is called a network. Every node in the graph represents a computation. These computations act on the edges, or tensors, and flow through the graph and ultimately produce a result that will flow out of the node. These computations are also referred to as operators. The tensors, or edges, are the data. The data is transformed by the nodes, and these transformations create other tensors, or edges. When we see these tensors flow through the graph, it's much easier to understand why Google called this TensorFlow. All right, in this lesson, let's move from the abstract to the real world and watch live numbers flow through our TensorFlow graph. I've placed a tensor symbol beside each of the numbers to show that they are the data, or the edges, of our graph. Our first step is to round up our values. As numbers flow into the nodes, they are acted upon, and in our case, they are rounded up. The top tensor is 2.6, and the tensor on the bottom is 1.5. The output of these operations is a 3 and a 2. Now let's multiply 3 times 2. Since 3 times 2 is 6, we simply output that value so it can be moved through the graph onto the next node. Since there's only one arrow flowing into the next node, on the top of our graph, the number remains a 3. Now let's multiply 6 times 3. That gives us 18 as the output for that step. Notice the 6 flows without change to the next node. Our last step is to multiply 18 times 6. This gives us 108, and this completes the TensorFlow graph.